So welcome guys. So today I'm gonna solve this question, that is top k frequent element. So in this given question we have given an array, that is nums, and integer k. So we have to return the k most frequent elements. So we can return it on any order, so order doesn't matter. So let me explain with the help of this test case, that is this test case. So let's understand with the help of this test case. So for example, if I have this test case that has element 1 1 triple 1 2 triple 1 2 2 2 3, and we have given the k, that is integer 2. So we have to find the uh, 2 we have to find the k, we can say we have to find the k two most frequent element. Okay, k. So in this we have to find the k most frequent element. So in this case two most frequent element we have to find. So here we can see that here 2 is uh, 2 is occurring 3 times. So it is, we can say, present more than 2 times. So it will be appear in the resultant, that is a resultant vector, that is resultant answer. And yeah, 2 also is, we can say, appearing more than or equal to 2 times. So we have to find the k, that is two most frequent elements in this nums. So the problem statement is simple, we have to find the k frequent elements. So but for this test case we have two, so we have to find the two most frequent element, that is 1 and 2. So we have to return 1 and 2. So how do we proceed with this question is simply the I will be explaining the first I will be explaining the brute force approach, then I will explain how to optimize it. So brute force approach is simple. What we will do, simply we will iterate over this array from 0 to n. Okay, 0 to n, and this outer loop will pick our any element. We can say pick any element, pick any element from the array, and I will declare a count variable inside this for outer loop, this outer for loop, that is 0, and one that is in my inner for loop. I will what I will do, I will start my loop from, that is I plus 1, that is if I is equal to 0, then my this inner loop will be start from 1, and this will be goes up to n. And simply inside this inner loop, what I will do, simply I will compare if my count, if that particular I can say that particular element is appearing more than or we can say equal to k times, more than or equal to k times, then I have to simply uh, push that element into my answer vector. So answer dot push that element, that is let's say I am writing this element as element. So I have taken one vector, that is answer vector. So we have to return the answer vector. So what we have done is simply I have taken two nested loops. The outer loop will pick the element, and this inner loop will count the number of times the particular element is occurring. So and we will see if our that count variable is greater than k, then we have to push that element into our answer vector, and then after that we have to return this. So let discuss the time complexity. So time complexity will be, so we are as we are the outer loop will be from starting from 0 to n. So outer loop will be running from 0 to n. Okay, and inside the this outer loop we are running another loop, that is also from 1 to n, that is equal to, I can say, in that is equal to n. So in worst case we have this is from 0 to n. So the overall time complexity for this brute force approach will be n square, and yeah, space complexity will be big O of n, as we are not using any extra auxiliary space, so that is big O of n, and time complexity will be n square. And yeah, that's the this brute force approach. Now we will come how we will optimize this solution, our solution. So here what we are doing, that repetiting work is simply comparing that element and increment our counter variable. So we are comparing uselessly, we can say, again and again. So we need any, we can say, any data structure that will store our that count of that particular we can say count of that particular element, and directly we can access, so that directly we can access that without so that without using any extra loop, or we can say this iteration, so we can directly access that. So what we will do, I will simply store take the unordered map, that is unordered map, and which will simply what this map will do, simply uh, store our array element. For example, if I have that is we have that test case, that is triple one double two, and that is triple one double two and 3. So what that element we will use is, simply we will store the count of this element along with the element. So for example, in this case, so here will be storing the, that is 1 comma 3 will be stored. So we are storing the element along with their count, that is 2 comma 2, and at the end we have 3 comma 1. Okay, that is 3 comma 1. So what we will do, simply mp of, that is nums of I, that is 1, nums of I plus plus. Okay, then for 0 there is 1. So nums of 0 will be, that is 1, mp of count will be, that is, so we will store that elements along with their count, and then what I will do, I will take the help of, that is max heap, that is min heap, because I have to we can say I have to return the top, we can say, most frequent element. So I need that min heap. That what we will do, simply min heap will carry the top element as minimum element at top. So and we will we will use min heap, that is priority queue, and in which, as we know that priority key is using, that is LeetCode, that is sorry last in first out, that is last in that is first in first out, sorry, that is FIFO principle, that is it is using the FIFO principle, that is first in first out principle. So what we have to do, simple logic is if our q dot size is greater than, we can say, if our q dot size, that is size of the q, is greater than k, then what we will do, simply we will pop the top element until our that q dot size is less than that, we can say, k, that is q dot pop. Okay, so we will simply check if our q is greater than that k, that is most frequent element, then we have to simply pop that first top element, that means minimum element, from this queue. So what I will do, I will store the count of, that is mp, that is, this will be it dot it. So we will we can store that these pair, these count and element count in the pair. So this will be accessed by it dot second. So we will insert these pairs into our queue, and pop that top element of the queue unless until it is less than, that is until it is greater than k. So this it dot second, that is it, that max, the maximum element will be at lower, that is at the last, and minimum element will be at top. So 3 comma 1 will be at last, and 2 comma 2 will be at second, and here will be 3 comma 1. Okay, 3 comma 1 will be there. So what we will do, simply we will check if our size of q, that is q dot size, is greater than k. Obviously it is greater than, because we have k equal to 2 and q dot size is 3. So we have to pop the top element from the queue. So now our queue become this. Now our queue will contain 3 comma 1 and 2 comma 2. Now what I will do, I have to return the element. We have to return the element. So what I will do, simply I will push that, we can say, second element of the queue inside my answer vector, that is answer dot pushback, that q dot second. I will put that second element inside my answer vector, and I will return that answer vector. So this is the whole solution, and we can say optimized solution for this. So let's discuss the time complexity for this, we can say, solution, optimal solution. So time complexity will be simply, first we will do simply that we will store the count of each element, will store the element into the map and along with their count. So that will take, because we are iterating the big O, we can say from 0 to n, so that will take big O of n plus, and we are using priority queue, and in priority queue, until our that queue become empty, then we will if our q dot size is greater than that k, so we can say the time complexity for this will be also big O of n. And let's just get the space complexity. Space complexity will be, I can say, big O of n, because as we are using the minimum, that is max heap, min heap, so that will take the big O of n time. So that's all for this question. So let's understand with the help of this code. So first is brute force approach. Simply we are using the nested for loop. The outer for loop will pick the element from this array, and second will be counting of each element. So if our count is greater than k, then I have to push that particular element inside my answer vector, and then we have to return that. Then second, that is optimal approach, will be simply I have to or we can say store the element along with their count. So that will be the code for this. And I am using the min heap because I have to return the most frequent element, and this queue, that is min priority queue, will be we can say use the principle that is LeetCode, that is FIFO, that is will be based on the principle FIFO, that is first in first out principle. And what we are doing here is simply inserting the second element, and so inserting the because we are inserting the second element, so the most least element that will be occur leastly, that will be at top. So we have to if our q dot size is greater than that, we can say if our q dot size is greater than k, then we have to return that, sorry, we have to pop the that top element from the queue, and then I have to they will store that pair then we will got that most frequent pairs. And then what I will do, I will empty my stack into until into our answer vector, that is q, we have to return the element. So q dot top dot second will give the that particular element, and then I have to push that element into our answer vector, then I have to return this. So this will be the optimal, we can say optimal solution. So let's run this code. I hope this will get accepted. So yeah, let's submit it. So indeed we have submitted this code. So let's meet in the next video, I can say. Okay.